Welcome to the video. Today we are going to solve another Math Olympiad problem. So let's look at the problem. Given that x is equal to 2017 to the power of 2017 plus 2017, and we have to find the remainder when this x is divided by 5, 6, 7 and 8. Okay. So let's use the plasma method. P stands for problem understanding. So we are given that our expression is quite a lengthy expression. If we expand this, and then we have to see how what will be the remainder. It is not asking about quotient because that's too tough to solve, but what will be the remainder when this is divided by either of these numbers. So this is the problem. Now we go to the next step, which is a linking of concepts. Whenever you see this word remainder, you think about modular operations or modular arithmetic. Naturally, one should lean towards modular arithmetic. I'll explain a little bit what it exactly means. And so that is going to be used here. Let me just write down. Now, assumptions. So far, we are not making any assumptions here. Now, next is we solve step by step. So let's understand what a modular arithmetic means. When we think of any number n and we divide it by another number 5, let's say in this case, then we will get a quotient and a remainder. So what n is in fact 5 times the quotient plus the remainder. Correct? Okay. Now this is, let's say, this is squared. So what we will have is n times n. So here it's 5 times quotient plus r. This is 1n, and then we multiply it by 5 times quotient plus r. This is another n. Okay. So when you multiply actually these numbers, you will get 25 times q square plus this will multiply with this. So 5 times q times r plus this r will multiply here, r times 5 times q, and then plus the r, 2 r's will multiply here, s r square, and we divide this. So this is n square, and we divide this. Let's say if you have to find the quotient, when we have to find the remainder again, when this is divided by 5. So we see that this number is divisible by 5, this number is divisible by 5, this is divisible by 5. The only thing we have to check is the square of the remainder for n square. And this is the key concept of modular arithmetic. We just have to divide this r square by 5 to know the actual remainder when n square is divided by 5. Everything else is already, we know that they are already divided. Only the r square term is remaining. We just divide that by 5 and then to find the next remainder for n square. The remainder for n is r. The remainder for n square will come from r square. Okay. So this is called modular arithmetic. We have 2017 to the power of 2017. Let's first just look at the first term here. So when this number 2017 is divided by 5, let's see what is the remainder. We have 4 times 20, then 1, then 0, 7, 5, sorry, 3 times 15, and then 2. So 2 is our remainder when 2017 is divided by 5. Okay. So we have to go another level when 2017 square. When we do a square of it, 2017 square, then that will be, as I said earlier, it will be r square. So this is our r. So for 2017 square, our R square will be 4. Okay. When you divide this by 5, what will you get? The remainder will be 4. 2017 cube will get R cube. So 2 square 8. So this will be 8. So here, let's say this is R1, this is R2, this is 4, this is R3. When you divide this by 5, you will get 3 as the remainder. And then 2017 to the power 4, we have to again do R to the 4. So that would be 2 to the power of 4, which is 16. When you divide this by 5, you will get a remainder of 1. Okay. Then 2017 5 is R to 5 is equal to 2 to the power 5, which is 32. When you divide this by 5, you will get the R5 as 2. So when you start seeing the same thing as 2 here, that means the next multiplication of 2, basically the square, another 2 multiplied, you will again get 4. Then you will again get 8. So the R3 will be this, again get 16. So R4 will be 1. So we have unique combination of 2, 4, 3 and 1 as the remainder. Okay. So these are the 4 remainders which will keep on repeating. Now we have to go until 2017. So 4 different remainders. Now we have to go until 2017. So we have to find out at which point it will stop. And we have to only find the remainder, right? The last digit actually. Yeah, the remainder. So 2017, you have divided by 4, you will get 5, 20, then 1 is 0, then 17 is 3, oh sorry, 4, so 16, and then 1. So meaning 504 times these 2, 4, 3, 1, 2, 4, 3, 1, 2, 4, 3, 1, this will repeat on and on and on. And then there will be 1 extra, so it will come back to 2. So the overall remainder coming from here will be 2. Okay. So 2017 to the power of 2017, when you divide it by 5, the remainder is 2. Then we have to add 2017, when you divide this by 5, at the beginning, the first time we saw that it also has a remainder of 2. So we have to add these two remainders, 4. So for 5, the remainder is 4. Okay. Okay. So now let's look at the for 6, what happened. I mean, this is the same way. So when you divide to 2017 by 6, you will get 3 times 18, so 21, then 3 times 18, 37, then 6 times 36, you will get 1 remainder. Whenever you get 1 remainder, just be really happy. Why? Why do I say that? Because if n is giving you R1 is 1, then n square R2 will also be 1 square, which is also 1. Then n cube is R3, which is 1 cube, is also be 1. So every of the term until we reach 2017, our final remainder is always going to be 1. Okay. For 6, 2017 to the power of 2017 mod 6 is 1. So all these multiplication is giving us 1 plus 2017 mod 6, which is the remainder just coming from the second term, is also 1. So we have to add them, right? We have to add these two remainders. So the answer is 2. So if it had been more than 6, then we would have again taken out one more 6 from it. So the remainder is 2. Now let's look at for 7. 2017 by 7. So this is 2 times 14 and 61. Then 8 times 56. Then 57. So 8 times 56. Again 1. Okay. So what we learned here, the remainder here will be 2, the same as this. So this remainder will come out here also. With mod 7, the remainder will come out 1. And this here also it will come out 1. So 1 plus 1 is 2. Then the last but not the least for 8. So 2017 divided by 8. Again 2 times 16. So 41. 5 times 40. So 17. So 2 times 16. So 1 again. So the remainder. So remainders for 5, 6, 7, 8 are, the first one was 4, the second one is 2, 2, 2. And this is our answer. So we have carefully monitored our calculations and this result is correct. Hope you like this video.